So in section 3.4, we're looking at solving quadratic equations by factoring. And for objective 1, we're going to look at solving quadratic equations of the form a times b equals 0. The first thing that we need to establish is just exactly what is a quadratic equation. Well, we know from our work with our parent functions that anything that has x squared as the highest power, right, is going to be quadratic. And in fact, our definition is a quadratic equation is one that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a doesn't equal 0. So the reason why a can't be 0 is if a is 0, well then we only are looking at bx plus c equals 0, which would be a linear equation. A linear equation is one that has the highest power of x being 1. So, quadratic, ax squared plus bx plus c, and we could set that equation equal to 0. So the first examples involve identifying equations as linear, quadratic, or neither. So looking at this one, we see 4 minus 5x to the first power equals 0, right? Anything that has the first power of x as the highest power, and it's a polynomial, is going to be linear. 5x cubed plus 2x squared minus x equals 0, while that's a polynomial, it's neither linear nor quadratic because it's cubic. And then x squared plus 2x plus 1 equals 0, that one is quadratic. Now, what we're going to be using to solve these equations by factoring is something called the zero factor property. And the zero factor property says, if I have a times b equal to 0, then what has to be true? Well, if a times b equals 0, then I know that one or both of those numbers have to be equal to 0, because that's the only way to multiply and get 0. So either a equals 0 or b equals 0, or both. So that would be what we're going to use in order to solve these by factoring. So here's an example of how that's going to work. Suppose that I have already factored for me x minus 2 times x plus 9 equals 0. Well, I know that either x minus 2 equals 0 or x plus 9 equals 0. That's the only way their product can be 0. So either x minus 2 equals 0 or x plus 9 equals 0. Now we have two linear equations to solve, right? And to solve the first one, I can simply add 2 to both sides. X equals 2. Or, on the other side, we're going to subtract 9. And we're going to get x equals negative 9. So my solution set include those two solutions, 2 and negative 9. And notice that we do have it inside of set bars because we're calling it the solution set. All right, so now you try the next one. Stop the video for a second. Try the next one and see what you come up with. So hopefully you pause the video and you are now restarting it, because you're going to have that either 4x minus 3 equals 0 or x plus 9 equals 0. So 4y minus 3 equals 0 or y plus 9 equals 0. So in this first one, we're going to go ahead and add 3 to both sides. Get 4y equals 3. And then we're going to do the opposite of multiplication, which is division. And we're going to get y equals 3/4, or in this case, we just simply need to subtract 9 from both sides. Y equals negative 9, right? Just get that down a bit. So my solution set includes those two solutions, 3/4. Let's not do it in green. 3/4, comma, negative 9. And if you plugged either one of those into the original quadratic equation, and it would be quadratic if we FOILed it out, right? If I FOILed this out, I would end up with x squared plus 9x minus 2x minus 18. So x squared plus 7x minus 18 equals 0. But in this case, they're already factored for us. Okay, so now these next two equations aren't technically quadratic because if we FOILed them out and distributed, we'd end up with cubic equations. But that same zero factor property still applies. So I'm going to say that either 5x equals 0 or 2x minus 7 squared equals 0. So in the first case, I can just divide both sides by 5 and get x equals 0, which makes sense because 5 times 0 would be 0, right? With the other one, if I expanded this, wrote it without the exponent, right, I'd have 2x minus 7 times 2x minus 7 equals 0. And there is no reason for me to solve that twice, so I'm just going to say 2x minus 7 equals 0. Solve it once, then I've solved it for both of those because they're identical. So I'm going to go ahead and add 7 to both sides. 2x equals 7, and then divide by 2. So x equals 7 halves. It just counts twice, but I only list it in my solution set once. So my two solutions are 0 and 7 halves. So even though it wasn't technically a quadratic, I can still use that zero factor property. And the same thing's going to apply for my last example, right? I just have 3 factors this time. I have t minus 2, I have 5t plus 6, and I have t plus 3. So go ahead and stop the video, see what you come up with in terms of your solutions, and then restart it and follow along with me and see if you get the same thing. So hopefully you paused and you did t minus 2 equals 0, or 5t plus 6 equals 0, or t plus 3 equals 0. So in the first case, simply add 2 to both sides, t equals 2. On the second one, you're going to have to do 2 steps, right? First, subtract 6. 5t equals negative 6, divide by 5. T equals negative 6/5. And the last one, simply subtract 3 from both sides. So t equals negative 3. So this solution set contains 3 answers, right? 2, negative 6/5, and negative 3. Okay, so in all of the examples that we have done so far, we have been very fortunate. Think about the reason why we have been very fortunate. These equations have they've been given to us already in the form where the left side is factored and the right side is equal to 0, right? Will we always be so lucky? You know the answer to that is no, right? So what we're going to have to do now is work to actually factor these quadratic equations so that we can get to the point where we can use the zero factor property. So as I note, in the examples above, the quadratic equation was already factored, and all we had to do was apply the zero factor property. In the examples that follow, this will not be true. So, steps to solving a quadratic equation by factoring. First, we have to set the equation equal to 0. Why? We want to end up with a times b equals 0, right? Because that's the magic that makes it work. If I had a times b equals 4, well, a and b could be any number of things, right? But if it's equal to 0, there's only one thing that makes that true. Either a is 0 or b is 0, right? Or both. So next, we have to make sure that the quadratic equation is in the form ax squared plus bx plus c equals 0. And why do we want to do that? Well, so that we can work with it and in the manner that we're used to. And we should always check to see if there is a greatest common factor as the first step in factoring. And if you notice that before this video, I did post another video with a review of factoring in it. Okay, so now we're ready to factor a quadratic, being careful to check our work, right? If you're going to use guess and check, remember it's guess and check, not guess and pray. And finally, we'll set each factor equal to 0, and we will solve it. Okay, so this first one, we have x squared plus 9x minus 22 equals 0. So we have our 0 on this side, which is what we need. And then if we look at this side, it's in the proper order, right? So now, what is our task? Our task is to come up with two numbers that multiply to give us negative 22 and add, so the negative 22, sorry, it's coming from here, and add to give us positive 9. Positive 9. So we're working backwards, right? So two numbers that multiply to give me negative 22 and add to give me 9, well, one thing that I know is if this last term is negative, then my two numbers that multiplied have to be opposite in sign. One's positive and one is negative, right? That's the only way to get a negative through multiplication. And I could start out by saying, okay, well, what if I had 2 times negative 11? That gives me negative 22. But 2 plus negative 11 is negative 9, so that doesn't work. What if I did negative 2 times positive 11? Well, that gives me negative 2 plus 11, which is 9, so it works. So I found my two numbers, and I'm going to show you the long method, and then we'll talk about how to do it quicker. So now that I found those two numbers, what I would do is rewrite my quadratic equation, taking that middle term and breaking it up using those two numbers that I found, right? So negative 2 plus 11 is 9. So 9x, I break it into negative 2x plus 11x. And this is factoring by grouping, right? So I'm going to group the first two, and I'm going to group the second two. And then the common factor for this first pair is going to be x. So x, if I factor out an x, what times x gives me x squared? X. And then what times x gives me negative 2x? Negative 2, right? Always bring down whatever that sign is. The common factor for 11 and 22 is 11. What do I multiply times 11 to get 11x? X. What do I multiply times 11 to get negative 22? Negative 2. And then at this point, I can always double check. X squared minus 2x, check, plus 11x minus 22, check. And then one thing that I notice here, and this is a very beautiful thing, is that these, let me change the color on that. These match, right? So I have a common binomial factor that I'm going to go ahead and pull out. X minus 2. And then what's left over is going to be the x plus 11 equals 0. And I could double check that as well. X minus 2 times x plus x minus 2 times 11. And so we can see now that we have it factored, right? And we can always double check our work as well. So FOIL, x squared plus 11x minus 2x is 9x minus 22, right? So now I know that either x minus 2 equals 0 or x plus 11 equals 0. Add 2, x equals 2, subtract 11, x equals negative 11. So my solution set, 2 and negative 11. Now, if you have done a lot of factoring before, you may notice that once we found the two numbers that worked, negative 2 and 11, because my leading coefficient was a 1, right, I could just go ahead and say x minus 2 and x plus 11. So this number goes here, this number goes here, right? That only works, though, if this first number is a 1, okay? So just be cautious about that. Okay, so now let's talk about this next one. And the first thing I'm going to do is check to see, I notice this is not a 1, right? So that makes me just a little bit sad, okay? Because it's going to make my problem a little more difficult. But I hope maybe there's a factor of 3 in all of these, but no, 3 doesn't divide 22, so I can't factor a 3 out first. So I'm going to go with my same method I was using before with one extra step. If I have a number that's not 1 here, I have to say 3 times 24. So I need a number that multiplies to 3 times 24, which is 72. I need a number that multiplies to 72 and adds to 22. So where's that number coming from again? Multiplies to A times C. Sometimes this is called the AC method. 3 times 24 is 72 and adds to 22. Now, one thing that is nice, if you notice, is that these are all plus. So my numbers are all going to be positive, right? So now, this is the part that makes factoring a little bit more challenging, is it's not immediately apparent what two numbers are going to work. But all I need to do is try all the possibilities. So 72, 2 times 36. But 2 plus 36 is 38. So that doesn't work. Does 3 divide 72? Yes. Just get your calculator out. 72 divided by 3 is 24. 3 plus 24 is 27. Still not it, but we're getting closer. Does 4 divide 72? Yes, it's 4 times 18. Aha! And 4 plus 18 equals 22. So we found our two numbers. Now we do the exact same thing we did in the first example. We go ahead and rewrite. And I know this seems like a lot of steps, but I would totally do it this way, okay? And I rewrite 3x squared. Break this up, and it doesn't matter which number you put first at all. So plus 4x plus 18x plus 24. Doesn't matter at all. You can put either one first, and it will not make a difference. So I'm going to go ahead and group the first two. This is also called factoring by grouping. And the second two. Now, my common factor for the first pair is just x. So I'm going to end up with x times 3x plus 4. Double check. X times 3x is 3x squared. X times 4 is 4x. Plus the common factor, greatest common factor for 18 and 24 is 6. 6 times what gives me 18x? 3x. 6 times what gives me 24? 4. Okay, so now this is beautiful once again because I have that common 3x plus 4. If you don't have that common 3x plus 4, then you know you've done something wrong. So I'm going to go ahead and take out that common 3x plus 4. And what's left is x plus 6 equals 0. So I take out what's in common, and what's left goes in the other factor. 3x plus 4 times x gives me this piece, plus 3x plus 4 times 6 gives me this piece. And now we know what to do, right? Either 3x plus 4 equals 0, or x plus 6 equals 0. Subtract 4 from both sides. Divide by 3. So x equals negative 4/3 is one solution. Subtract 6. X equals negative 6 is the other solution. So there's my solution set. And, factoring, if it's been a very long time since you've done it or it's not your favorite thing to do, then just remember that there is a process. That process is very methodical. And if you need more practice, go back to that video that I have about reviewing factoring. Okay, so now let's take a look at this one. What do you notice? Ask yourself, what do I need to do to make this the right form for me to be able to go ahead and solve this problem? Hopefully you noticed it's not equal to 0. So let's go ahead and add 60 to both sides and get that thing equal to 0. Now, sometimes I put a little smiley face because I need to remember that I need a 0 on that side, right? Okay, so now, and I also noticed that my leading coefficient is a 1, which is a happy, happy thing, right? So now I know that I'm just looking for two numbers that multiply to give me 60. And I'm using the same rule, right? Because this is just a 1. So 1 times 60 is 60, right? So that same process is working. And then add to negative 16. Okay, so here's a pro tip. If this is positive, then the only way that can happen is a positive times a positive or a negative times a negative. Well, how do I know which one it is? The sign right here is going to tell me, right? So I know they both had to be negative factors. And if you need to go through them, go through them. Negative 2 times negative 30, well, that adds up to negative 32. That's not going to work, right? Negative 3 times negative 20, that adds up to negative 23. That's not going to work. I'm not writing it out now, but I'm showing you how to go through it. 4 and 15 is not going to work. 5 and 12 is not going to work. But negative 6 times negative 10 does work. Right? And because I know that leading coefficient was a 1, I don't need to go through the whole grouping thing. You can if you want, but I know it's going to be x minus 6, x minus 10 equals 0. If you want to go over on this side and do the grouping thing where you break that negative 16 up into negative 6x minus 10x in group, go ahead. It's good practice. But because that leading coefficient was a 1, we don't really need to. We know where those numbers go. So now either x minus 6 equals 0 and x equals 6, or x minus 10 equals 0 and x equals 10. So my solution set includes those two numbers. Okay, now same thing here, right? It's not set equal to 0, but I would really dearly like this x squared coefficient to be positive, so I'm going to go ahead and subtract 81 to the other side. And this is going to be 25x squared minus 81 equals 0, right? Now, we've got it in the correct form, but hopefully you notice that we're missing an x term, right? It's 25x squared minus 81. So I have a couple of options here, and I think the simplest one is going to be for me to realize that I have the pattern a squared minus b squared, which is called the difference of squares. So often people talk about algebra as being the science of patterns, or math is the science of patterns. You're looking for patterns, right? Because this would be like 5x squared minus 9 squared equals 0. And the nice thing about noticing that is it always factors the same way, a plus b times a minus b. Because I would get, if I FOILed this out, a squared minus ab plus ab, so those middle terms cancel, minus b squared. So that's one to have in your back pocket and be well aware of, a difference of squares. Now, so I'm just going to go ahead and fill in my pattern. 5x plus 9, 5x minus 9. Double check my work. 5x times 5x is 25x squared minus 45x plus 45x, cancel each other out, minus 81. Difference of squares. There's a lot of power and noticing patterns like we talked about with our parent functions and the transformations, right? So now either 5x plus 9 equals 0 or 5x minus 9 equals 0. So go ahead and subtract 9 from both sides. 5x equals negative 9, divide by 5. X equals negative 9/5, or add 9. 5x equals positive 9, divide by 5. X equals positive 9/5. So 9/5 and negative 9/5. There's my solution set, right? So hopefully this is making sense to you. And remember, if not, you can always go back and watch the videos again, or you can email me and ask for some more help. So one thing I noticed about this bad boy, not equal to 0, and it's sort of started factoring over there, but this isn't going to help me because this isn't 0. So the first thing I need to do is I need to go ahead and multiply this out so that I can then get it into the right form. So if I FOIL this out, I'm going to get y squared plus 4y minus 3y minus 12, right, equals 8. Combining my like terms, y squared plus 4y minus 3y is 1y, minus 12 equals 8. Then I need to go ahead and subtract 8 to get it equal to 0, right? So y squared plus y minus 20 equals 0. Okay, now, that just made us do a little bit of extra work here, right? So now I need two numbers. So I've got that positive leading coefficient, right? Two numbers that multiply to give me negative 20 and add to give me 1. And if you need to run through the possibilities, go ahead and do it. I know they have to be opposite in sign, right? So I'm going to go with positive 5 times negative 4, just in the interest of time on this video, right? Because 5 times negative 4 is negative 20, and 5 plus negative 4 is positive 1. So because that leading coefficient is a 1, I can just go ahead and put those numbers in there, right? And then if I set this one equal to 0 and solve, I'm going to get what? Negative 5. Set this one equal to 0 and solve, I'm going to get 4. So there's just one extra step that we had to do, right? Okay. Now, this one, same sort of situation, right? So let's go ahead and distribute, right? So order of operations says I can't do what's inside these parentheses, so I need to distribute before I can do anything else. So I'm going to get 6y minus 12 minus 3y minus 3 equals 8. Oh, this is not quadratic, right? I don't see a y squared term, so this one's going to be quick. Combining like terms over here, I got a 6y and a negative 3y, so that's going to give me 3y's. Combining those, right? Negative 12 and negative 3 is negative 15 equals 8. It's not quadratic, so I don't want to set it equal to 0, right? Now, the next thing I need to do is go ahead and add 15 to both sides. So 3y equals 23, right? And then go ahead and divide by 3. So y equals 23 thirds. Because it's linear, I only have one answer. So that one was pretty quick and very much easier, right? So, you know, just because it's an equation in this homework, don't be thinking, oh, well, they're not going to throw a linear one in there. They will. Okay. So now, higher degree of polynomials by factoring. At this point, the only way to do one like this is to factor by grouping. And you notice they've given us 1, 2, 3, 4 terms, right? So I'm going to go ahead and group these two and these two, and hopefully it's going to work out because it's already equal to 0, right? So my common factor for these two is going to be x squared, and I'm going to be left with 2x plus 5. Bring down that sign, minus. Greatest common factor for 18 and 45 is 9. So then I'm going to have, what, 2x plus 5, right? Because negative 9 times positive 5 is negative 45. And look at that. I have a common factor. So following along, oops, and then 0 equals, pull out that common factor, 2x plus 5, and then I have an x squared minus 9. So then 2x plus 5 times, now hopefully you notice that is the difference of squares, right? X squared minus 3 squared. So that's x plus 3 times x minus 3. It's that difference of squares pattern that I need to be able to recognize. So now I've got 3 possibles, right? 2x plus 5 equals 0, or x plus 3 equals 0, or x minus 3 equals 0. So subtract 5, 2x equals negative 5, divide by 2, negative 5 halves. This one subtract 3, this one add 3. So there's my solution set. I got 3 answers for this one. Yeah, because it was a cubic, right? Okay, so now this one, we're going to need to distribute and set it equal to 0 before we begin, right? So go ahead and pause the video and see what you come up with. So this one's going to be x cubed plus 7x squared equals 4x plus 28. It's not equal to 0, but we can fix that, right? Subtract these two to the other side. X cubed plus 7x squared minus 4x minus 28 equals that magic 0, right? Group and group. First pair has an x squared in common. X plus 7. Bring down. Second pair has a 4 in common. X plus 7, right? Because remember, I want a negative 28, and that 4 is negative. Then look at this beautifulness. Common factor. So x plus 7 times x squared minus 4 is what's left over, right? Equals 0. Hopefully you notice I've got that pattern, that difference of squares. X squared minus 2 squared, right? X plus 2, x minus 2. So now either x plus 7 equals 0 and x equals negative 7. X plus 2 equals 0, x equals negative 2. X plus 2 equals 0, oops, minus 2. X equals 2. So there's my solution set on that one. Now, the last 3 problems in these notes are word problems, application problems, but they're not so bad as could be because we're going to be able to draw a picture for these. So it says the length of a rectangle is 3 yards more than twice the width x. The area is 629 square yards. Write an equation in terms of x that represents the given relationship and solve it to find the dimensions of the shape. So the first thing I'm going to do is I'm going to draw a rectangle. Notice it says twice the width x, right? So I'm going to let x represent the width. And then I need to write the length in terms of the width using x. And it says the length of the rectangle is 3 yards more, so plus 3, then twice the width. Twice the width is going to be 2x. So this would be 3 yards more than twice the width. This is going to be equal to the length. Because they're telling you about the width, or the length, and using the width to do it, the width needs to be the variable. And then you can go ahead and write an expression that will tell you what the length is if you know what the width is. Okay, and it says the area is 629 square yards. Well, we know area for a rectangle is length times width, right? So 629 is going to be equal to the length, which is 2x plus 3, times the width, which is x, right? Now, this is in the quadratic equation section because first thing we have to do is go ahead and distribute our x, right? So we have 629 equals 2x squared plus 3x. You can distribute from the left, and you can also distribute from the right. You just need to make sure that both of these terms get multiplied times x. And we can see that we're looking at a quadratic. How do you solve a quadratic equation? Well, you need to set it equal to 0. So 2x squared plus 3x minus 629 equals 0. Because I'm going to go ahead and subtract 629 from both sides so that I can end up with that lovely 0 that I like so much. Okay, so now this is kind of a sad thing because my leading coefficient is not a 1, right? Also, I'm really, really sad about that really, really big number, 629, right? Because I know that in order to solve this quadratic equation, I need to be able to factor it. And because my leading coefficient, a, is not equal to 1, I need to multiply a times c in order to figure out what I need to find, those two numbers, right? So 2 times negative 629 equals negative 1,258. So I need to find two numbers that multiply to give me that and add to give me positive 3. Okay. Now, I'm not going to just start guessing just randomly because those numbers need to be really close to each other so that they'll have a difference of 3, right? The one number's positive and one number's negative. So only way I'm going to get negative 1,258. So they're going to be opposite in sign, and when I combine them, they're going to be very, very close to each other so that I'll get a positive 3. The bigger number needs to be positive, the smaller negative, but they need to be close. So in order for me to think about where to start, I'm going to go ahead and I'm going to take the square root of 1,258. This is just off to this side. It's just to give me somewhere around which to start. It's about 35. So I'm going to start by asking myself, well, is 1,258 divisible by 34? And it is. So it's 34 times 37. And when you look at that, they differ by 3. So the negative number needs to be the smaller. Negative 34 times 37 is negative 1,258. And when I add those together, I'm going to get a positive 3. So that's a really good technique to use if you're asked to factor something that has such big numbers. It's nice that I know that what the add to is so small, so those numbers had to be close. And that's why I use the square root, because 35 and something times 35 and something would give me 1258. So I'm going to go ahead and say, well, let's try one less and see what the other would be. They'll be close to each other, and their product will be close to 1258. That's how I came up with that. Now, I'm going to go ahead and I'm going to use my factor by grouping method, right? 2x squared, and it doesn't matter how I break it up, minus 34x plus 37x, right? Minus 629 equals 0. So I'm going to go ahead and erase this so it won't be in my, oh, can't erase it. I'll go ahead and move it so it won't be in my way. I can't do that. Well, we'll just have to pretend like it's not there. Okay. I already did something else, so I can't erase it. So I'm going to go ahead and group. My first pair has a 2 in common and an x in common. So 2x times x minus 17, 2x squared minus 34x. Bring down my plus. And I'm thinking it's probably going to be 37, yes. And that 37 times 17 is 629. So I'm going to factor out a 37, and that's going to be x minus 17. So I just took my calculator, and I said 629 divided by 37, and it turned out to be 17. And so, wonder of wonders, we have a matching factor. So I can go ahead and factor that out. X, oops, I'm going to use pen. X minus 17 times 2x plus 37 equals 0. Now I can use my zero factor property. Either x minus 7 equals 0 or 2x plus 37 equals 0. Adding 17 to both sides gives me x equals 17, or if I subtract 37, I'll have 2x equals negative 37 and then divide by 2. So x equals, let's see, 37 divided by 2, that's negative 18.5. And while that's a perfectly acceptable solution to this quadratic equation up here, it doesn't make any sense at all if we're thinking about x being the side of a triangle. Sides can't be negative, right? So we have to go ahead and we have to throw that out. It doesn't make sense. So we're left with our answer, which is 17. It's going to be 17 yards, right? So the width, why am I using blue? The width, which is x, equals 17 yards, and the length is 2 times 17 plus 3. 2 times 17 plus 3 is 37. So width is 17 yards and the length is 37 yards. So this one had quite a bit going on, right? We had a word problem. Drawing a picture helps us organize. We ended up with a polynomial, a quadratic with really big numbers, but we were able to use those patterns that we noticed in order to make our work quicker. Okay, so we have another one. This one is about a triangle. The length of the longer leg of a right triangle is 2 feet longer than the length of the shorter leg x. The hypotenuse is 2 feet shorter than twice the length of the shorter leg. So one thing that I notice is we're talking about a right triangle. We know that a right triangle has a 90-degree angle, right? And it says the length of the longer leg, so this would be the longer leg right here, right, is 2 feet longer than the length of the shorter leg, x. So let's let the shorter leg, in fact, let me go ahead and redraw this where one of them has a shorter leg and one of them has a longer leg. Doesn't really matter, but. So the shorter leg is x. The longer leg is 2 feet longer than the shorter. And the hypotenuse is 2 feet shorter than twice the length of the shorter leg. So twice the length of the shorter leg and 2 feet shorter. So now we've got a right triangle. We have expressions for the two legs and one for the hypotenuse. And we know that Pythagorean theorem applies, right? So x squared plus, in parentheses, x plus 2 squared equals, in parentheses, 2x minus 2 squared. Now this one's going to be more work, right? Because this one's okay. This one I have to multiply it out. This one I have to multiply it out. And if you need to go ahead and write this as x plus 2 times x plus 2 and 2x minus 2 times 2x minus 2 so that you don't make a mistake with your multiplications, then do it. So this is going to give me x squared. This one's going to give me x squared plus 2x plus 2x is 4x, right? So x squared plus 2x is 4x, plus last 2 times 2 is 4. Again, x times x is x squared. 2x plus 2x is 4x. 2 times 2 is 4. Equals. Now I've got 2x times 2x, that's 4x squared. And then I've got negative 4x and another negative 4x. So 2 negative 4x's is negative 8x. So 4x squared minus 4x minus another 4x is minus 8x. And then last is plus 4. So now I'm looking at, over here, if I combine like terms, I've got 2x squared plus 4x plus 4 equals 4x squared minus 8x plus 4. Okay, so I'm looking at a quadratic equation that I need to solve. And I'm just going to go ahead and I'm going to subtract each of these over here, because I want that a, that leading coefficient, to be positive. So I'm going to say minus 2x squared minus 4x and minus 4. So over here, these are all going to add to 0. And that's going to give me 2x squared minus 12x, and those add to 0. So just watch your signs there, right? Oh, wow, that's great news, because I don't have a constant, right? So I can just look at this and say, do I have a common factor? And I do. There's a 2x in common to both of those. So if I factor out a 2x, what am I going to be left with? X minus 6. Let's double check. 2x times x is 2x squared minus 2x times 6 is 12x. Now that could have been much worse, right? Because either 2x equals 0 or x minus 6 equals 0. Dividing both sides by 2, I get x equals 0, which makes no sense for this side of a triangle. And over here, add 6, we get x equals 6. So what are we talking about? Feet, right? So find the dimensions of the shape. So the shortest side, and I'm not sure how Alex will want this, is x, which is 6 feet. The longer side is x plus 2, which is 6 plus 2 is 8 feet, right? And then the hypotenuse is 2 times 6 minus 2. 12 minus 2 equals 10 feet. So on all of these, you just can't let yourself get overwhelmed when you read those words and you're like, I don't even know what to do. Draw a picture, think about it. It's going to give you one of the things that it wants to be x, and then you can express the other missing things in terms of that x. And they saved the easiest one for last, because we're looking at a right triangle, and they want us to find the hypotenuse, which we'll call c. So we know that 12 squared plus 16 squared equals c squared. Well, 12 squared is 144. 16 squared is 256 equals c squared. So c squared equals, well, 256 plus 144 is 400. So you have two options here. You could either subtract 400 from both sides in order to set it equal to 0, and then recognize that you're looking at a difference of squares. C and a C, 1 plus, 1 minus, and 20 and 20. Right? So either C plus 20 equals 0, which doesn't make sense in this context because the side of a triangle can't be negative, or C minus 20 equals 0, add 20 to both sides, and C equals 20 feet. The other option is, when I'm looking here at c squared equals 400, I'm going to take the square root of both sides. So c would be the positive and negative square root of 400, and the square root of 400 is 20. Now again, the negative doesn't make any sense in the context of this problem, so we end up with c equals 20 feet. So because I have a perfect square equal to a constant, I have that option available to me as well.